this example will illustrate how to get a statement as a goal in order to derive the falsum. So here we're trying to get not P or not Q by a not elimination proof. And so our goal at the moment is a falsum. And so we look up in our premise, in all the statements above, and we see what our potential goal, what our potential contradictions are. And at the moment, the only potential contradictions we have are it's false that P and Q, and if we could create P and Q, or it's false that not P or not Q, and if we could create the statement not P or not Q inside this box. So we want to have, but it's unclear from what we have how we're going to get started on that. So what we need to do is we need to create one of those statements as a goal. So what you do is, I'm going to pick this one here. It's false that not P or not Q. So you click on the statement that you're going to use as part of your contradiction, and then you click on the falsum, and then you click falsum introduction. And it'll say, okay, if you want to do that rule, then you need these two things. And so when you click apply, it will put the thing you don't have as a goal, which means it's something now that you can work towards. So let's do that. So I'm going to try and get this by or introduction. Let's see if that works. And I don't know, I'm going to pick or introduction right. Why not? Okay. And so I say, well, I want to get not Q. How am I going to get not Q? There's no obvious way to get not Q. So I'm going to try to get this by not introduction. This is a very counterintuitive proof. This is one of the proofs of De Morgan's laws. The others are much simpler, much more straightforward. This one's weird, and I hope I'm doing it right, because I forget how it goes every time I do it. But let's try this. So I'm going to try to get this by not introduction. Don't know if this is going to work. Don't think it is. This isn't going to work. I'm not doing it right. All right, back up. I think I went wrong at my first. I should have made the other statement my goal. Okay, so let's try making P and Q my goal. So I'm going to select it's false that P and Q and the falsum, and then it'll make P and Q a goal. Okay, yeah, this is going to work. All right, so let's get this by and introduction. That seems like a reasonable way to get this. If you have an and statement you want to create, you get the two parts and you stick them together. Okay, so now I need to get P, but it's not clear how I'm going to get P. So I'm going to try to get that by not elimination. Okay, so now I need to get from not P to the falsum. Let's just focus on that. Well, I could get to, from not P, I could get to not P or not Q. And then I could use line 2 to get my falsum. And so I could do that just by clicking on not P and clicking on or introduction right. And then I could type in not Q. And that's going to work just fine. But instead of doing that, let's do that trick again where I get not P or not Q as a goal inside this box here, because then I can work it backwards. So I'm going to use the falsum introduction here, and it puts not P or not Q as a goal. And now I can work this backwards so I don't have to type, because I'm lazy. So I want to do or introduction right. Okay, so now we've got our P. So now we need to get Q. So we're going to do that by the exact same strategy. So we try to get Q by not elimination. That gives us a not Q to work with. So inside this box, we make not P or not Q a goal by Falsum introduction. And then we do or introduction left, and we're done. But that was a very counterintuitive proof. I don't necessarily expect you to have come up with that proof on your own, which is why I did it for you. And it also enabled me to illustrate this neat trick with the Falsum introduction.